Hi, I'm Jem from Ontotext. I have a background in publishing, so I used to work at the BBC and the Financial Times, and we built platforms that use some of the technology that I now engineer at Ontotext. And we're engineering a platform that follows some of the lessons I learned working for those publishers. So coming from a publishing background, there's always unstructured, ambiguous content. And then we introduce some technology in our platform that allows us to deal with that in a way that you can generate value. And I'm going to show you some of that and explain some use cases. So, unstructured, ambiguous content. So this travel journalist obviously has been waiting for this story all of his life and has decided that he's you can see here, is it a traffic jam or is it jam? This one is quite interesting. Was it brief time or was it brief pants? You get the idea. Is this murder or is it cooking? We have... So in this case, we're looking at linguistic analysis, and you can see that this is prepositional word sense ambiguity. So was the painting found and located by the tree, or did the tree actually find the painting? So at Ontotext, we do lots of things around looking at language and understanding the language so that we can really understand what it's about. And we obviously have databases that manage our content and understand the domain that people are working in. So we don't use traditional relational databases because they only understand information. They don't understand the connections between data, the relationships. They don't understand knowledge that's contained within your data model. We have a database that allows you to have really rich connections to really describe your domain so that you can publish content within that domain, so you can make really good understanding. And our graph database sort of acts in the way that a human brain does. So human brain have memories, and those memories are in context with each other. And you have a set of rules that you build up over time, so how you act with those memories. And our graph database allows you to capture resources and relationships between those, but also allows you to have sets of axioms and rules that you can apply against those, so that you can infer additional knowledge. So you put your data in, those rules get processed as you put your data in, and new facts and new data comes out. So we're in semantic web. I love Tim. He is a person, but he's also a mammal. So, sorry, a person is also a mammal. So by inference, we can deduce that Tim is also a mammal, not just a person. So we have that ability within our database to reason and infer additional facts. But it's not just an axiom rule-based database. We also use statistics and we use vector spaces, so we can do similarity and entity awareness, and we can concord data as well as matching data. So if you were writing a story and it was about certain things, we could recommend content that is similar to that content based on the fact that it's very close in the vector space. But use the graph context as well. So you can use the knowledge of the domain and statistical model together to find really close comparisons in data. And big knowledge graphs provide awareness. So the larger the database, the more statements you have, the more facts, the more knowledge you have in there, the better the answers you get from it. So we can store billions and billions of statements, and we can answer questions like, tell me all the airports that are near London. What's the most popular banks? Who in the news is mentioned along with the company Apple? We can describe all those entities, and we can describe those entities in context with your news or your content. And we do that using a graph, but also the vector space. So you can use the vector space. This is an example here. It's a really, very simple example, but you have a couple of documents that mention things that are about a car, so engines and tires and models. And you can see that the purple and blue documents are quite close in the vector space, and therefore they're similar. And you can also do things about entities. So within the graph, graphs have attributes that describe the entities within the graph. And you can do similarity based on vector space, not just on documents and content, but entities. So if you were building a knowledge graph about companies, for example, you might want to bring in lots of data sets that are about particular companies, and we could find similar types of companies or the same companies based on the fact that they're statistically close in the vector space. And we built a platform that allows you to analyze your content. So we do text analytics. That's based on natural language processing, machine learning. Allows you to do concept suggestion, classification, sentiment, relationship, etc., etc. Pass through your content. It will do all of those pieces of analytics based on your knowledge model or your graph. And we link our text analytics pipeline, which does basic standard NLP stuff. So it does things like language detection, tokenization, part of speech, all the basic things, but also links the text analytics pipeline to the domain that's in your graph so that you get context. So in this example here, we're saying Apple and Tim Cook are mentioned in a paragraph, and therefore, because Apple is quite close to Tim Cook in the graph, we can give confidence to the fact that it is Tim Cook, the CEO of Apple, and we can therefore give high-quality extraction results because we use not only machine learning models, but we use a graph that describes the world. And machine learning isn't perfect, and you need to train the model, but you also need to create the model. So we have tooling that allows you to, as text analytics produces suggestions, you might find novel entities that aren't in your domain graph that you might want to add into your graph. So you might want people to have a human interface that checks things, concords things, made use of similarities, and then put things back into the graph so you can make your domain model and your knowledge model learn and improve. And then, because we're annotating all of our content, we can then retrain the machine on those documents. So as we add novel things and confidence and relevance scores, we retrain our machine learning models based on that cyclic approach. So as content gets processed, we find new things, those things get added to the content, but we also retrain the model to find those things again when those things turn up again in content. Yeah, so we analyze content, we store a fingerprint of the content. So a fingerprint would be something like this. So a piece of content is annotated with entities in your graph with particular scores, and we have a knowledge graph that describes Apple, Tim Cook, and Samsung and its relationships to other organizations. And you say this content has some sort of relationship. In this case, it's mentions, about, but we have located, all sorts of different predicates to describe the relationship between entities in the domain graph to pieces of content. You therefore create a model that really understands your content really well. All of your pieces of content are interlinked within a graph, and means you can query it, discover new entities, and traverse through the graph and your content to find new uses for your content. But we also understand users, so we capture users, their personas, what they're interested in, and interlink those with the knowledge graph as well. So we capture the behavior of users as they use the content. So we capture a behavioral profile as a user traverses through content, scrolls through content, clicks on content, or dwells on content, or moves away from content. And that profile becomes a semantic fingerprint of the user. We can combine the semantic fingerprint of the user with the semantic fingerprint of pieces of content, and then before we can recommend. How much time have I got? 6 minutes. I'm talking really quickly, sorry. Yeah, we understand user behavior and social behavior as well, so we can mine Twitter and get behavior as people use social news. We index those in the platform. And given the semantic fingerprint of content, the semantic fingerprint of users, the behavioral patterns, and the fact that we have vector space models and similarity models, we can then do recommendations. So we can say this piece of content is like this piece of content because it mentions the same sort of things. But we can also say this piece of content is relevant to this user because he acts in a particular way. He acts like a CTO because he's looked at the types of content that a CTO looks at. Or he's been commenting on a particular piece of content that someone else has had interest in. And we create those profiles so that we can do interesting recommendation. All of those things combined mean that you can get increased engagement with the content. So content in context with the knowledge graph, so the domain that you're interested in. Understanding your users in context with the domain that you operate in. Understanding the user behavior and the social behavior. And all of those things combined with an API that allows you to traverse and query that data means you can build really, really exciting products. And I'm a technical guy, so you might fall asleep and be bored, but this is the very high-level architecture of what we build. So we ingest unstructured content, we normalize it, so it might be, I don't know, video, audio, we transcribe it, it might be plain text, we work out the language, we tokenize it, but we'll also ingest structured data, so data sets that describe a domain, so it might be locations, so we might bring in geonames, it might be financial data, so we'll bring in SNP or FactSet or some data set like that. We join those together and we put them in a graph. And then we create what we call a semantic fingerprint across all of those things, allowing us to store content, do concordance, search across it, annotate and store those user events, do the text analytics, the NLP and machine learning, recommend, and truly understand content and how it's being used. We have a set of APIs across it that then allows you to build applications, such as the IAT's example earlier. So, this semantic publishing approach means that authoring is simpler. So when I was working at the BBC, we had to do the site for the World Cup with only 10 journalists, and for the Olympics, there was about 15, 20 journalists for, I think it was 10,000 index pages. The only way the BBC could attempt to publish that amount of content to those aggregation pages is to automate it. So it speeds everything up, it increases quality, it allows you to search for it, and allows you to re-aggregate your content and build products upon it. So this is what we're repeating it. I don't have much time. So authoring, editorial, production, delivery, it helps all of those things and makes them better, obviously. I'm a salesperson. But yeah, so when I worked at the BBC, we used, and it still does use, the architecture that I designed, which is all about analysing the content that's been authored by the journalists, tagging it, putting it in with ontology models within GraphDB, Ontotext graph database, having a set of APIs that allows you to traverse it. So when you go to the BBC Sport page, the Chelsea page, the football page that you should go to because it's the best football team, that's all served from GraphDB, and we've understood that it's about Chelsea, the football team, and Frank Lampard, etc., etc. And the IAT, the use case that Tim mentioned earlier, is using GraphDB as a knowledge base, and it does all of the text extraction, so identifies things like scientific, numeric entities, but also novel entities that haven't had in their thesaurus before, so they can add those back in, and allows them to aggregate the content and create analytics products on top of it. And if you're interested in any of this, there's some demos you can take a look at. So there's the Now demo basically takes lots of public news feeds, does extraction on it, aggregates them, and builds a nice pretty UI on it, so you can get a sense of how you might use it as an application. We do ranking of companies, so that say you can say if you're looking to buy a company or as a merger and acquisition, you can see which ones are relevant, how they're ranked, using the vector space model. And FactForge is a great big knowledge graph that we've created from all the public sources that are out there, things like Wikipedia, DBpedia, geonames, and it shows you how you can create a brain of knowledge within our graph database. Yeah. So that's me.